Next quality attributes to consider is interoperability, what it is about. So this quality attribute is about the degree to which two or more systems can usefully exchange information, can communicate between each other. This communication can have different perspective, but the systems may have been constructed with an intention of exchanging information. They may be existing systems that are designed to exchange information, or they may provide general service without knowing the details of the system that wish to utilize those services. Two important aspects of interoperability. It is discovery and handling of the response. About the discovery, what it means, that the consumer of a service must discover the location to identify and the interface of the service. So another one part of communication, the consumer must discover the location to which they will be able to communicate. Handling of the responses, there are three distinct possibilities: that service report back to the request with a response, service send its response to another system, or the broadcast its response to any interest parties. Let's take a look for general scenario. Here you can see the general scenario for interoperability. Let's take a look more detailed. So here we have the same structure of source, stimulus, artifact, environment, and response measure. What can be under the source? The possible values for the source can be: the system initiates a request to interoperate with another system. It can be the source of the action. The stimulus, the request to exchange information among systems. Artifact, the place where this action can happen. So in which this, not where, but what kind of artifact we're working with is the system that wish to interoperate. Environment, system wishing to interoperate are discovered at runtime or known prior to runtime. So you have to determine is it happen on runtime or in which environment it is. What kind of responses can be in for such a quality attribute? It can be one of or more of the following. For example, the response can looks like: the request is rejecting and appropriate entities are notified. The request is accepted and information is exchanged successfully, or the request is logged by one or more of the involved system. This is kind of proposed responses to choose one of them or several of them. Next, we have to measure our response to understand that we will satisfy this quality attribute, these architecture characteristics. What kind of measure can be for interoperability? For example, percentage of information exchanged correctly processed, or percentage of information exchanged correctly rejected. So when you have the measure, you can measure your responses in this case, and will be able to answer for the question for the stakeholders of the system: is your system satisfy the requirements of interoperability or not for particular cases? Here is the sample of concrete interoperability scenario that can be. For example, let's say our vehicle information system sends our current location to the traffic monitor system. The traffic monitor system combines our location with other information, overlays this information on a Google map, and broadcasts it. Our location information is correctly included with probability of 99.9%. Based on this information, this is the input that we have. Then from the previous slide, we can take the general scenario. And based on this general scenario, we should build the concrete scenario. And by the way, it will be your next practicing task. According to your domain, you have to build, based on general scenarios, the concrete scenarios. Here it can looks here this scenario will look the next way. So what is the source of our stimulus? The source of our stimulus, according to this input, is our vehicle information system. It will initiate what? So the stimulus will be current location sent. This is the action that produced by our stimulus, which is our vehicle information system, which sends current location to what? Sends to whom? To traffic monitor system, which is running where? Which is working on system knows prior on runtime. And what kind of response we are expecting? We're expecting that the response of our traffic monitor system to this stimulus will be that the traffic monitor combines current location with other information, as it is mentioned here, with our location with other information, overlay this information on a Google map, and broadcast. How can we measure our response? So the measure of this response is that our information includes correctly 99.9% of the time. Here is the concrete example of a quality attribute for interoperability. Now let's take a look what kind of tactics we can use to achieve to satisfy this quality attribute on the next stage. So now let me quickly remind you that tactics in general, they are like a bridge between quality attributes and in future the patterns that you will be working on or you will choose, because sometimes patterns can combine different quality attributes. So this is like an intermediate step to choose the correct approach and make a decision which kind of patterns will be suitable to cover your quality attributes. And one more quickly reminder that quality attributes or architectural characteristics is the result of stakeholders communication. So they have to prioritize what is important or not. So here we have the list of tactics for interoperability. They can be divided into two categories: the locate and manage interface. The locate, it is, for example, it can be the tactic that can be used is discover service. There is only one tactic in this category, and just discover the service. It is used when the systems that interoperate must be discovered at runtime. It's locate the service through searching a well-known directory service. So for this, maybe I can say as an example, for example, there is an Eureka where the services can register and they are discoverable for all other services, and other services can find them and work with them. Another one category of tactic, it is manage interfaces. So here is two tactics. It's orchestrate and tailor interface. Orchestrate is generally, this is how it names. It's about orchestration. So orchestrate is a tactic that uses a control mechanism to coordinate and manage the sequence of invocation between different services. For example, it can say, okay, I will get the request to the orchestrator, then orchestrator will know how to behave in this case, how to behave in this scenario. The first execution, the first request should go to this service. It should give me the response, or the next request should go to another one service. Then from that service go to another one service. Then from second to the third one, and so on, so on. So it can build the internal sequence of invocation between services. Mostly it is used in microservice architecture when you have a lot of different services and you're trying to orchestrate the process. There are cons and pros from these tactics. For example, it's quite hard to support cross transactions between services, to keep state, to how to behave or when the fault is happening, how to orchestrate back all of this sequence of action. It's one of the complex issues. So I would say that it most can be used when there is that the service, the coupling between service is low, and cohesion is quite good for them. Another one tactic is tailor interface. Tailor interface is a tactic that adds or removes capabilities of some particular interface. Capabilities, it means such as translation, adding buffering, or something like this. That's all about the tactics and general interoperability. And next will be modifiability.